So, good evening, one and all. So, today we are going to discuss about the exact sampling distributions. So, which is very important topic in the statistics and especially in the statistical inference part also. It plays a very crucial role. So, chi-square distribution is one of the important distribution in the exact sampling distribution, and another important distribution is T distribution. Student T distribution also plays a major role in the exact sampling distribution. And also another important distribution is F distribution. It is also plays a vital role in the exact sampling distributions. So now we are going to deal these topics one by one. And first of all, it's a chi-square distribution. So the chi-square distribution is very important because of many statistical tests are approximately distributed in the chi-square. So two of the more commonly using in the chi-square test deviations. Difference between the mainly the chi-square purpose is the difference between the how to calculate the difference between the theoretical expected value, expected frequencies and observed frequencies, and also we can find the relationship between the categorical variables. So whenever we want to check the association between the categorical variables, on that time we are using chi-square tester. So it is very important topic, and especially whenever our data have a qualitative data, in that situations chi-square distribution plays a major role. And also the chi-square distribution is the definition of the chi-square distribution, the square of the standard normal variate. So the square of the standard normal variate is also known as a chi-square distribution. So chi-square distribution have a 1 degree of freedom. So whenever if our x value follows a normal distribution, then z is equals to x minus mu by sigma is follows a standard normal variate. Whenever that standard normal variate we squared it, automatically we will get a chi-square distribution, which means that z square is equals to x minus mu by sigma whole square with 1 degrees of freedom. So chi-square distribution, the definition here, the square of the standard normal variate is also known as a chi-square distribution. So chi-square distribution, chi-square distribution graphs executed like this. See, it is a almost stretched more than one side. See, observe the pattern of the chi-square distribution graph. See, this graph is stretched more than one side, that is a right hand side. Because of chi-square distribution, values always get the positive values. So positive values greater than 0, that is the reason chi-square distribution stretched more than one side. So that is why because of here we are squaring the standard normal variate. Squaring, whenever square the value, automatically it will become a positive value. So that is the reason the graph of the chi-square distribution executed more than right hand side. It is stretched more than right hand side. So that is the reason the graph would be appeared like this. And also we have some properties in chi-square distributions. So mean of the chi-square distribution is n. So mean of the chi-square distribution n, and variance is 2n. Mode of the chi-square distribution curve lies at the point n minus 2. So whenever we want to calculate the moment generating function of the chi-square distribution, the moment generating value of the chi-square distribution is 1 minus 2t whole power minus n by 2. And also characteristic function, we can simply apply the I value. So it is imaginary value 1 minus 2 2it whole power minus n by 2. So chi-square distribution have a skewness and kurtosis. So skewness is beta 1. We know that skewness is represented always with the beta 1. So that is the beta 1 skewness means it's a chi-square value 8 by n. 8 by n. Kurtosis value. So kurtosis is always represented with the beta 2. Beta 2 is equals to 3 plus 12 by n. Therefore, we conclude that the chi-square distribution have a positive skewness, and also it is a greater than 3, beta 2 greater than 3, which means that the chi-square distribution is in the sense in the leptochatic. So chi-square distribution have a positive skewness, and also it follows a leptocosis. So that is the reason the graph appear like this way. So chi-square distribution have some of the greatest applications in the common life. So in the statistical lives also. Whenever large number of applications statistics, first of all, to test if the hypothetical values of the population variance. So whenever we have a data in population variance, we can test the hypothetical values through the chi-square distribution, and also to test the goodness of fit, how our model would be fit or good or not. So we can measure by the chi-square test, and also we can test the independence of attributes. Attributes means we know that the qualitative data, it represents smoking and non-smoking habits or non-habits, as a yes or no. So these kind of attributes, whenever if we want to check the independence of the attributes on that situation, we can use the chi-square test, and also to test the homogeneity of independent estimates of the population variance, and also combine the variance probabilities obtained from independent experiments and give a single test of significance. So many vast applications are developed by the chi-square distribution. So chi-square distribution plays a vital role in the exact sampling distribution. And another important distribution is that is a student T distribution. So we know that the random sample size n and follows the normal population with mean mu and variance sigma square. So T is equals to formula x bar minus mu by s by root n. We know that s bar means sample mean, s square means variance 1 by n minus 1 summation xi minus x bar whole square. So the sample variance is unbiased estimator of the population variance. So whenever the distribution, the student distribution particularly follows n minus 1 degrees of freedom, the density function automatically would be appear like this: 1 by square root of t beta of 1 by 2 comma t by 2 plus into 1 by 1 plus t square by t into t plus 1 by 2. So this is a density function of a T distribution. So the T distribution always lies between minus infinity to plus infinity. So this graph similarly looks like a normal distribution, because of we know that a normal distribution stretched minus infinity to plus infinity. Similarly, student distribution is also close to the normal distribution. See, above the curve is represented the blue color line. This curve represents the normal distribution, and a red color curve is represented the T distribution. So almost it is closer to the normal distribution. That is the reason the limit values of the T distribution is minus infinity to plus infinity. If we want, go to for example, chi-square distribution. Chi-square distribution has stretched more than one side, that is a right side. If you want this chi-square test follows normal distribution or not, whenever your degrees of freedom increasing, if you want increase your degrees of freedom, automatically this curve is also tends to the normal distribution, close to the normal distribution curve. So that T distribution also close to the normal distribution, but there is no need to increase of the degrees of freedom here, because of it is already close to the normal distribution comparatively chi-square distribution and F distribution and also. So in this T distribution we have some of the important properties. One is all moments of odd order is 0. So if our order is odd numbers of the all moments is 0, and also the T distribution of the mean of the T distribution is 0. So third and fourth moments given by the 0 because of here. So third moment is an odd moment, so that mu3 equals to 0. Here the mu4 is 3n square by n minus 2 into n minus 4 for n greater than 4. So for n greater than 4. So beta 1 equals to 0. Beta 1 equals to 0, which means that skewness is 0. Beta 2 is equals to 3 into n minus 2 by n minus 4 for n greater than 4, which means that kurtosis exists. Here the kurtosis is beta 2 greater than 3. Beta 2 greater than 3. That is the reason here the T distribution follows the cutting. And also mode of the distribution, T distribution lies at origin, T is equals to 0. So if our n is equals to 2, if our n is equals to 2, the probability density function of a T distribution reduces automatically 1 by pi into 1 plus T square, which is a called standard Cauchy distribution. So this is the main important properties of the T distribution. Whenever if you want to perform a applications T distribution in live situations, whenever our sample size less than 30, n less than 30, on the situations, we can test the significance of the sample mean when the population variance sigma is unknown. And also we can test the significance difference between the two sample means and also population variance. And also we can check the significance of the observed sample correlation coefficients or difference between means of the two samples. So these are the major benefits of the T distribution and chi-square distribution of the exact sampling distribution.